Okay, this podcast is for CNT140. We're looking at Chapter 12 on Gigabit and 10 Gigabit cabling technology. They have some objectives here of touching on our fiber Gigabit and 10 Gigabit standards, as well as copper Gigabit 10 Gigabit standards, including some other technicals along the way, some technicals that support this information as we go. Before we begin, a couple intro concepts. Remember, Gigabit refers to a billion bits per second, one with 9 zeros behind it. That is kind of becoming more the norm for data rates to our desktop. And as we work with 10 gig, that's 10 billion bits per second, often 10 gig E or 10 gig. This is becoming more the standard for backbone links between our closets, between our switches, that kind of thing. So just kind of putting those in perspective. Now, before we dig into standards and those sorts of things in this chapter, let me just kind of put a couple things in perspective for you. If I were to go out and buy a switch today, so let's just go, we're going to pick on Cisco, we're going to go to their switch page. Let's say I want an access switch. That's kind of the switch that's out near the users, the kind of stuff that would be in our closet. And I want to look at their, I want to see all of their switches, if you will. Let's see where they have them. Let's go switches, access switches. Oop, I'm going to go back this way. I'm going to go here, and I want to see show products. There we go. I'm going to pick the product line, kind of close to what we have, the kind of stuff that would be in our data closet. And I want to see the compare models on this guy. Here we go. Now we're getting traction. This is what I want to see. This shows me the product line with the model number, port count, etc., etc. Well, if I look at just the top one right here, this model number, 48 ports of 10, 100, 1000. So that would handle gigabit to the desktop computers that plug into it. I then have my uplinks of 2 SFP ports. Well, the SFP ports are just that. They're blank ports on my switch that I need to buy an SFP module to plug into it to give me an uplink port, to give me a connection to another switch. Well, I typically need to buy those modules, SFP modules, for what I'm connecting. And I can actually buy copper SFP modules and fiber SFP modules. After we go over our standards, we'll come back and kind of touch on this and look at ordering an SFP module so you understand how to start using these standards to our benefit. Just kind of putting in perspective why they're throwing all this stuff at you and kind of the useful side of it. Gigabit Ethernet, IEEE 802.3, 802.3Z standard was really for fiber. They did not think copper could do gigabit, so they approved the fiber standard first, 802.3Z, in 1998. Then along came the 802.AB standard for copper in 1999. They realized, oh, I guess we can do copper. So it was one of those kind of fiber kind of introduced first because they thought that was the only thing that could do gigabit, and then along came copper. It's kind of an interesting little tidbit. The original idea was gigabit was going to be fiber, and then we found out that things like 5E can handle gigabit, so the copper standard came along. Reminder for you, Ethernet is, just plain old Ethernet is considered 10 meg, fast Ethernet is considered 100 meg, gigabit is your 1000 meg or 1 gig, 1 billion bits per second. And they remind us that gigabit is topologically similar to fast Ethernet, same old star topology. So we're still going to cable everything the same from our closets out to the workstations. Remind us almost all multi-mode fiber will handle gigabit. It roughly more than double the copper distance. Category 5E can handle, but we need to have really good installation techniques to do this, and our distance is still limited to 100 meters for gigabit Ethernet. Here's where they start giving us some standards. 1000 base, remember 1000 is your bandwidth, 1000 meg is 1 gigabit. Base is baseband, and if I pay attention to the last 2 letters, they're usually telling me something about, in this case, my fiber wavelength. If this were 1000 base T, I knew it was twisted pair. When I start seeing other letters, I can kind of, in my brain, jump right to fiber and focus in on the letter to tell me something about the wavelength. S is roughly short wavelength. That's your 850 nanometer. Your L is your long wavelength. That's typically your 1300 nanometer wavelength that you deal with, 1310, 1350 kind of thing. And then you have the SLX, super long. That is your highest wavelength that you would run into, your 1550 nanometer wavelength. So that's one way to kind of sort these out real quick. Well, if I jump over to my price source over here, I'll pick on CDW, and I want to order a 1000 base SX SFP. If I use that standard now to my advantage and say I want that particular SFP, ooh, it looks like I'm not getting that. Let's try one more thing. Let's do Cisco SFP. Let me try it this way. I should be able to turn up something here for me. Well, there's a 10 gig, there's a 1 gig. Here we go. Here's a 1 gig module for us, and I would find out that this is actually a different part number, but this is our Gigabit SFP module that I would have, and this would be your 1000 base SX. There you go. 1000 base SX SFP module. This would handle roughly 300 meters kind of thing, roughly half mile point, kind of thing, that ballpark. 850 nanometer, your short wavelength. This is where you start using your standards to your benefit. That is telling you what it is. 1000 base SX, short wavelength. This would be good for short multi-mode fiber runs. So that's where this stuff actually starts coming in handy to denote what module I need for my port on my switch and those kinds of things. That's where it actually starts coming in handy. This is the summary chart that was in the book. I kind of recopied it for you just for reference. For me, just kind of start looking at these letters here to know short, long, super long, and that'll tell you your wavelengths, and then the distances kind of go along with that. Your short is going to be a short range, your long is going to be longer, as you're up to 5,000 meters, and then your super long 10,000 meters. It's gonna go up as the wavelengths go longer. Several factors affect our bandwidth. We have, or I should say, several factors affect the bandwidth and range of our gigabit links. The bandwidth of transporting optics, the spectral width, chromatic dispersion, laser versus LED, and the actual fiber attenuation itself. Let's try to touch on each one of these. The bandwidth of transporting optics, the launch, the transporting optics sending the light down the length of the fiber. This is a limiting factor. The LED is used in lower speed transmissions, but it does not have the speed for gigabit. The laser diode, being a little more expensive, has the necessary speed for gigabit links. So typically we're going to start finding laser diodes for our gigabit links. They remind us of spectral width and chromatic dispersion, the second piece. If you remember, spectral width was my light source producing only a few wavelengths of light. And that kind of thing comes from your laser diode as opposed to the plain old LED. That's your ideal source. And I put this reminder in here from our, I think it was chapter 5 and 11. The surface emitting diodes give off a wide range of light. That's your typical LED light source. Edge emitting diodes produce a less number of wavelengths of light. And this one is usually the better choice, and this is where your gigabit optics come from. There's your surface emitting and your edge emitting diodes. So your laser diodes, this is the one that has the better optics for our gigabit fiber, and I put these in to kind of remind you what they're looking like. There's your edge, your surface emitting surface on our laser diode, and here reminding you LED has a spectral width of typically 150 nanometers. Meanwhile, your laser diode has a spectral width of about 5 nanometers. A lot less wavelengths being emitted, so therefore a lot less wavelengths of light to be affected by the bending. And because of the bending, a lot less chromatic dispersion because of that. So this is all part of producing what I need for the gigabit link. I'm reminding you this from our earlier chapters that we talked about. Because of this, the spectral wave chromatic dispersion, the impact of this, great deal of multi-mode fiber has been installed for future networks. Problem, to get the gigabit speeds, I need the laser light sources. So I have less problem. The laser light is a focused beam, single ray of light going down through. when I have imperfections with my fiber, that could cause fatal refractive errors. So some of the fiber that was installed a long time ago was not of good enough quality for this, because that can cause a problem. With this, I have differential mode delay. This is the phenomenon of mode of light arriving slightly behind another mode, and this is one of those when I start dealing when I start bending my light and getting the different wavelengths of light bending and getting dispersed a little bit, I can have this differential mode delay. That's the part of the dispersion. This problem has little effect on LEDs, but has a little effect on LEDs. Problem does not occur in your single mode fiber because I have that single ray of light, if you will. So that's kind of the better way to go with your laser light source. I have less of these problems that they're talking about. The third one, laser versus LED, well, my LED does not have the optics necessary. I typically use my laser light source for these gigabit, but if I'm dealing with older fiber that cannot handle the gigabit optics, I actually need what's called a conditional launch adapter. This is an actual cable designed to kind of spread the laser light out that would go through the multi-mode fiber. And this is when I start running laser through multi-mode fiber that really can't handle it, I can have all kinds of problems. So this kind of detunes the laser a little bit so it runs through the multi-mode fiber. It's kind of a makeshift way of using your existing fiber. It's just kind of one of those, if you have to do it, that's what you need to do. It would be better to put your gigabit capable fiber in, but that's not always possible. Last thing they mention is fiber attenuation. This is kind of a review of stuff we mentioned before. Your multi-mode fibers are going to attenuate rather quickly. Your single mode's a lot less. And this is kind of a reminder as the wavelength increases, as the wavelength goes from 800 up to 1500, we're going to get less attenuation. My longer wavelengths are going to go a greater distance. And I put this in as a reminder from one of our earlier chapters, just reminding you your multi-mode wavelengths attenuate rather quickly, your single modes not quite so much. As we move into copper, I think this is actually a good place to stop, and I will come back to the next podcast here with your copper gigabit standards.